Okay, guys, so we're going to look at some two-dimensional tricks and tips. So sometimes you're working on an area problem or a composite area problem, and you need to find some additional information. So here's just a list of some of the things that you might want to jot down and look for. Okay, so sometimes you're missing a side that's parallel to another side, and you can add segments together or subtract segments from each other to get missing values. A lot of times if you have right triangles, you could use the Pythagorean Theorem to find a missing side of that right triangle. And if you have a missing length on a coordinate plane, you could always utilize the distance formula or the Pythagorean Theorem, which the distance formula is derived from. If you're putting two shapes together, you need to make sure you remember to add the areas. If a shape is cut out of another shape, then you need to subtract those areas. A fraction of a shape is when you multiply the area by a fraction. So if I have half of a circle, you find the area of the circle and then you divide by 2 or multiply it by 1/2. And a lot of times you need to subdivide or partition irregular shapes into shapes that are found on your formula sheet. A radius is constant throughout the circle, so if you have a radius or a diameter that is matched up against another shape, then it might share a side with the radius or diameter, depending on how it looks. And the perimeter of a polygon is always going to equal at all sides. So if you have a hexagon that has 6 sides, you add all 6 sides. And also the radius is going to be diameter divided by 2, and diameter is going to be twice the radius. So just make sure you remember all of these and keep them in mind when you are problem solving. So right now, first I see that I have a triangle. So I'm only going to be using formulas that are underneath the triangle. So for the area of a triangle, I look here and the area is 1/2 times the base times the height. So I would write that area down. And that area equals 1/2 the base times the height. Okay, so now the base and the height actually have a perpendicular relationship, and the base is one of the actual sides of that triangle. And the distance, the perpendicular distance from that side to its opposite vertex or the opposite angle is going to be the height. So the base in this situation is 7, and that height or vertical distance that the base would have to rise to get up to that vertex would be this missing side over here. But I see that this is a right triangle. So whenever I'm missing a side in a right triangle, this is one of the situations in which I can utilize the Pythagorean theorem. So I'd have a 3 and a 5, and if you recognize this pattern, it's actually a 3, 4, 5 triangle, which comes up often as a Pythagorean triple. But if you don't recognize it, you could use the Pythagorean theorem and write a squared plus b squared equals c squared. Remember, a and b are the legs that create the right angle, and c is the hypotenuse that's across from it. So 3 squared plus b squared is equal to 5 squared. Then I would subtract 3 squared from each side. And then I would take the square root of both sides, and my answer of b would be the square root of 5 squared minus 3 squared. So I see 5 squared is 25, and 3 squared is 9, and the square root of 16 is 4. So I see that that missing height of the triangle, or that side of the right triangle, is going to be 4. So now I can put the 7 and the 4 into my formula, and the area is going to be equal to 1/2 of the base, 7, times the height, 4. So once I put those inside parentheses, Then I can multiply, and 1/2 of 7 times 4, which is 28. So 1/2 of 28 would be 14. And since this is an area, whatever units you have, those units are going to be squared. So if it's centimeters, you're going to square the centimeters. All right, so 14 units, whatever those units may be, squared would be your area. Now for the perimeter, there is no perimeter formula underneath this polygon. So I am going to make one up. Perimeter always equals add all sides for all polygons, even irregular ones. So perimeter is adding all the sides, and I have 1, 2, 3 sides that make up the outline of this shape. Now, a lot of people see the 3 and the 4. And those aren't being utilized because they're part of dashed lines. They are measurements, but they're not lengths of the actual side. So the first side I already have, which is also the base, and that's 7. And the second side is 5 because it actually creates the outline of that triangle. But then this third side, I don't know, that is missing. Luckily enough, I could see the bigger right triangle that uses that green side as the hypotenuse. I can use that bigger right triangle and the Pythagorean theorem to figure out what that last value is. I'm going to use segment addition because 7 plus 3 is 10, so the full length of that bigger right triangle is going to be 10. So this is another instance where I might use segment addition. All right, so now I have 4 on this side and 10 on this side, and I'm trying to find that hypotenuse. So a squared plus b squared equals c squared, and then I have 10 squared plus 4 squared equals c squared, and then I would take the square root of both sides, and c is that hypotenuse, which is across, always across from the right angle. So after that, when I'm trying to find c squared, I take the square root of both sides, so I could just get c rather than c squared. 10 squared is 100, and 4 squared is 16. So the square root of 116 is what c is equal to. Now, the square root of 116, it's an irregular number, and I'm just going to round that later, but I'm just going to say that side 3 is the square root of 116. And since I'm just adding it and I'm going to be rounding to the nearest hundredth place, I'm not going to bother simplifying it in this format. But if you wanted the exact number, then you would need to do the 7 plus 5 plus, so it would be 12 plus whatever that square root of 116 is simplified. So I'm going to just add the square root of 116 here, and then I'm going to see what that estimation is in the calculator. So 12, because 7 plus 5 is 12, and then that 12 plus the square root of 116 ends up being 22.77. And I cut it off after that last 7, and the next number after the cutoff was 0. So since the first number that I deleted was 0, I'm not going to bump that last 7 up to an 8. And I changed it to squiggly lines rather than to straight lines for the equal sign because that means about equal. It's showing people that I actually estimated. And that's going to be normal units. So 22.77 units for my perimeter. Okay, so now we're going to move on to a rectangle. So for the rectangle, we're going to use the perimeter and area formulas that are here. However, I don't see any measurements. So when I don't see any measurements, but it's on a coordinate plane, I could take the 2 endpoints of a side and put that in the distance formula, but I actually prefer to just draw some right triangles, and because those two right triangles are congruent, I know that AD and BC are congruent, so I really only have to do the Pythagorean theorem once to find out the width of that or the length of that rectangle. So I'm going to utilize the Pythagorean theorem again, and write a squared plus b squared equals c squared, and I'm using that yellow triangle for the Pythagorean theorem right now. So 1, 2, 3, 4, 5, 6 squared plus the other leg 1, 2 squared. And remember, I can't count diagonals like that because that would be like square roots and radicals. Okay, so now I could use the distance formula, but I think this is much simpler. 6 squared is 36 and 2 squared is 4. So 40 is equal to c squared, and I want to take the square root of both sides of that equation to cancel out the square on the right side so I could see what just c, or the hypotenuse, is. And I get square root of 40. Now I'm not going to simplify that quite yet because later in the problem it doesn't really matter. Okay, so my width is square root of 40. And width and length are kind of interchangeable for your rectangle. Base and height for your triangle aren't really interchangeable unless it's a right triangle. Okay, so now I have some green right triangles, and that right triangle has a leg of 1 and a leg of 3. So 1 squared plus 3 squared equals c squared. 1 squared is 1, 3 squared is 9. That means that c is going to be equal to the square root of 10 because I had to take the square root of both sides. So now I know what the width and the length are, and I can get rid of my Pythagorean theorem work, and I could actually figure out what the area and perimeter are. So the area is going to be relatively easy. The area is going to be the length times the width. And that's going to be the square root of 10 times the square root of 40. And then I multiply what's underneath the radicals together, and I would get the square root of 400, which is a nice number of 20. So if you wanted to do the square root of 400, then you see that you get an answer of 20. And that's going to be my area, and that's going to be 20 units squared. So 20 units squared, and that's my area. On to perimeter. That's going to be doubling the length plus doubling the width. And if you wanted to just add all sides, you could just do square root of 40 plus square root of 10 plus square root of 40 plus square root of 10. But there's going to be 2 of the widths and 2 of the lengths. So this formula just makes a lot more sense. So I'm going to plug in square root of 10 for the length and square root of 40 for the width. And when I double them, the parentheses just go away, and it's just 2 square root of 10 plus 2 square root of 40. Now I'm going to show you how to do this with a simplifying radicals way, and then I'm going to show you how you could have just typed that entire line into Desmos calculator and gotten the right answer. So 40 is 2 times 2 is 4 times another 10, which I could break apart with 2 and 5. Okay, so 2 times 2 times 2 times 5. But I could take the square root of, so 2 times 2, I can make that into a perfect square. So 2 times 2 is actually 4. And then when I take the square root of 4, that is a 2 that gets out from underneath the square root symbol. So I am going to multiply the 2 that got out of the square root symbol by the 2 that's already there, and that 2 times 2 is 4. So 4, and I still have 10 underneath. So now that the square root or those radicals are the same, I could add those radicals together. And that would be your simplified radical. And if you type that in, if you want an approximation, then 6 times the square root of 10 is 18.97, and then I have a 3 that got cut off, therefore the 7 does not get bumped up to an 8. Now I could have just put in the 2 times the square root of 10 plus 2 times the square root of 40. I could have just typed that in. So the perimeter is about equal to 18.97 units, but if I just wanted that approximation, I could have skipped everything here, and I could have just typed it directly into the Desmos graphing calculator. And I get the same answer. Okay, so my final perimeter answer is 18.97 units.
Yes.
All right, so now we're going to move on to the parallelogram. Now, every parallelogram, a rectangle, a rhombus, a square, would actually work with this base times height formula as well, but we have more specific formulas that fit those shapes better. All right, so we have the base is going to be one of those two parallel sides that are also congruent. And so we have area equals base times height, and the base there is 10. And that, so we're going to put a 10 in for the base, and then the height is going to be the distance, the perpendicular distance between those two parallel bases that are also congruent. So that distance is going to be found over here with the 5 inches. So 5 inches would be the height. So this is relatively easy. You put in 10 for the base, and we put in 5 for the height, and then 10 times 5 is 50. And it's inches, and it's area, so it's inches squared. So 50 inches squared is the area. Now for the perimeter, we want to add all sides. So we just need to know that for a parallelogram, opposite sides are congruent. So the opposite parallel sides happen to be congruent, and we can see that the perimeter is going to be those 4 sides, side 1, side 2, side 3, and side 4. We're going to add all of those together. So I am going to take, okay, so the top and bottom are congruent. So I'm going to take those 2 10s, and then the left and right sides are congruent, and I'm going to take those 2 6s. Okay, so 10 plus 10 is 20, and 6 plus 6 is 12, and together that makes 32. So the perimeter is 32 inches all the way around the shape. All right, so now we're going to do a trapezoid, which kind of looks like a triangle that's gotten the top cut off. Okay, and that formula is going to be for the area, we're going to have area equals half of the height times the sum of the two. All right, so area equals half of the height times the sum of the two bases, and the two bases are the two sides that are parallel to each other. Okay, so the two that are parallel to each other, those are going to be the two bases. It doesn't matter which one's base 1 and which one's base 2 because I'm adding them. So 7 and 4 would create the two bases, and those could be interchangeable. I could have done 4 and 7 or 7 and 4. Okay, now the distance between those two parallel sides, similar to the parallelogram, is going to be the 2 centimeters, and that's going to be the height. So I'm going to plug those in, and we see that the area is half of the height, which is 2, times the base 1, which is 7, plus base 2, which is 4. And then we close the parentheses. All right, so we are going to rewrite everything, and we're going to do parentheses first. So the addition inside the parentheses is going to be 11. 7 plus 4 is 11. And then half of 2 is just 1, so that kind of cancels itself out. And then 1 times 11 is just 11. Or you could have done 2 times 11 is 22, and then half of 22 is 11. So now we have 11 centimeters squared as our area. Now, there is no formula for perimeter, but I see that the trapezoid has 4 sides. So I'm going to go side 1 plus side 2 plus side 3 plus side 4. Now, sides 1 and 2, I kind of already have because I'm looking at the 7 and the 4, which were the two bases. So the two bases of 7 and 4, I already have. Now, if you're looking at the 2.2, that's the third side, and 2.8 is the fourth side. So yellow, that pink and red, pink and green make up the 4 sides of that trapezoid. The red height does not, because that's a dotted line and it doesn't follow that outline. So 7 plus 4 plus 2.2 plus 2.8 actually follows what we want. And 7 plus 4 is 11, and then we have 2 plus 8 is 10, so we carry the 1, 2 plus 2 is 4, plus 1 more is 5. So we have 11 plus 5 is 16. So my perimeter all the way around that distance is 16 centimeters. Remember, area is units squared, and perimeter is just normal units. Okay, so now we're getting into hexagons, and this is probably the first time you've worked with area and perimeter having to do with regular hexagons. Now, if you draw a hexagon, we kind of saw that we could have 6 regular equilateral triangles created. So where they all meet in the center, I could see that we have a 30, 60, 90 triangle if we cut that equilateral triangle in half. And that's kind of where you're seeing the square root of 3 in there, is with those special right triangle situations. So because of those special right triangle situations, that's kind of where this area formula is coming from. So if you have the distance from the center to the midpoint of one of the sides, that's called the apothem. And we do not have that. We only have one of the sides. So the only formula that we can use is actually this top formula on our formula sheet. So we can see that the area is equal to 3 times the square root of 3 over 2, that fraction times one side squared. Okay, so that side is going to be 12. So I have 12 squared. So 3 times the square root of 3. I could just type everything in over here real quick and get my approximate answer. But if I want it to be in simplified radical form, I'm going to show it this way. And 12 squared is 144. And then if we simplify the top and bottom of those fractions that are going to be multiplied anyways, divide the bottom by 2, divide the top by 2, I get 72 on the right side. And then 72 times 3 gives me 216. So I have 216 times the square root of 3. And that would be the exact area. Or we could have typed this entire thing in, if I just wanted an approximate answer, I could have typed the entire thing into the Desmos calculator and gotten my decimal approximation, which is 374.12. And the next number is a 2, which is too low to bump the 2 up to a 3. So I have 374.12 inches squared. For perimeter, I have a regular hexagon, so that means all 6 sides are the same. So I can multiply one side length by 6, and I would have 6 times 12, which would give me 72. Okay, so the perimeter of this regular hexagon would be 72 inches. Okay, so now this one has the side length and it has what's called the apothem. So we have the apothem here that's perpendicular to the side. And now we can use this bottom formula if we want. If you wanted to use the top one and throw just the side in there, you totally could. So this one is 1/2 of the perimeter times the apothem. So the perimeter is going to be 6 times one of the sides. So 6 times 4 is going to give me the perimeter. Now, a lot of people just put the 4 in for the perimeter, but 4 is a side, not a perimeter. The perimeter is 24 because 6 times 4 is 24, and that's what you put in for P. P stands for the perimeter. So 1/2 of the perimeter, which is 24, times the apothem, which is 2 times the square root of 3. Okay, so first off, I would take 1/2 of 24, and that would equal 12. And then I'm going to multiply that by 2 times the square root of 3. So 2 times 12 ends up giving me 24, and that would give me 24 times the square root of 3. And that is my area. However, if I wanted to approximate that, I could just put the entire, I could have put the entire formula in here. 1/2 times 24 times 2 times the square root of 3, and I would have gotten 41.56. However, when I have 41.56, I have the next number is a 9, so I'm going to bump that 6 up to so the 9 was cut off, that 6 gets bumped up to a 7. So 41, not 4, sorry, 41.57 units squared, and that perimeter is going to be 41.57 units squared for the area, and I already found out the perimeter of 24 units. All right, so now I'm going to use the formulas underneath the circle because I have a circle here. And we need to make sure that whenever it says R, we are giving it the radius. Whenever it says D, we are giving it the diameter. Okay, so right now I see the diameter is 18 inches because the 18 inches goes all the way across the circle, and it also goes through the center of that circle. So I would have a diameter of 18 and a radius of 9. First off, we don't have a perimeter in this situation. We call it a circumference instead. So we're going to change that perimeter to circumference, but it's basically the same thing. But I can't add up all the sides in a circle because there aren't any sides to add up. All right, so first up, we are going to find the area, and area equals pi r squared. So pi is 3.14, and the r, or the radius, remember we need to make sure that we know that this is the diameter of 18 inches, and the radius would be half of that, or 9. So I'm going to use a 9 for this formula, not just the first number that I see. You want to identify what kind of numbers you have. And then 3.14 is multiplied by 81, which is 9 squared. And then 3.14 times 81. All right, so we do 3.14 times 81, and I get 254.34. And that's in inches. So 254.34, and that's inches squared because I'm working with an area. Now, for the circumference, you have two different formulas. One formula uses the radius and one uses the diameter. We have a diameter, so I would suggest using the circumference that involves the diameter. Okay, so circumference is equal to pi times d, or the diameter. Pi is 3.14 and the diameter is 18, so 3.14 times 18 is going to give us 56. Okay, so that gives us 56.52, and that's going to be normal inches because the distance around could be used, could be measured with measuring tape. Now make sure you don't use the pi that's in here because that's too many digits for what your Virginia SOL standards are. Maybe another day down in your future you would want to use more digits of pi to be more precise. But right now it's not necessary. Okay, but if I were to use 2 pi r, then I couldn't put 18 into that formula. I would need to put that 9, that radius in so that the 56.52 matches. Alrighty, so let's try to find some composite area. First off, I'm going to subdivide it into two shapes that I know. So I see a triangle that's highlighted in yellow, and then half of the circle, which is highlighted in green. So I can see that triangle put together with half of a circle gives me that full shape. So when I put that together, I would need to find the area of each of those sections, and then I would need to add those areas together. So let's do the triangle first. Okay, and then I would need to find the base and the height of that triangle. So it is a bit difficult. Okay, so the area is 1/2 of the base times height, and it's a bit difficult because we don't have that base. It doesn't look like we have that base. However, we have this radius of 9, and the radius of that circle is constant all the way through. So on the left side and the right side, I have 9 and 9. So that means if the radius is 9, that diameter is 18, and that diameter is shared with the base of that triangle. So the base is actually going to be equal to the diameter, which is 18. So then I have 14 for the height, and now that I have the base and height of the triangle, I can plug that in. So 1/2 of 18 times 14, and the area equals 0.5 is the same thing as 1/2, so 0.5 times 18 times 14, and I get 126, and that's in feet. So area is going to be 126 feet squared. But that is just for the triangle. I still need to find the area for half of that circle. Okay, so I'm going to find the area of the circle, and then I am going to take half of that area, or divide it by 2. So the area of the circle is going to be 3.14 radius squared, or pi r squared. So 3.14 times the radius of 9. So 9 squared is 81, and then 3.14 times that 9 squared, or that 81, is going to be 254.34. So that would be the area of the entire circle, but I want to take half of that area, so I need to take half of both sides of that equation. Remember, formulas are equations. Okay, so I would need to take half of that, so I would take that entire amount and divide it by 2. And then I would get 127.17 feet squared. So then I need to take that 127.17, and I'm adding it to the 126 square feet from the triangle, and I get 253.17 feet squared. So now that is my final answer. So sometimes you need to take a fraction of an area, sometimes you need to put areas together, and sometimes the radius or diameter actually gives you more information about another shape. One more composite example for you. All right, so for this one, I have a square, thinking about like a square piece of construction paper, and then it's like I'm cutting out or taking away a circular piece of construction paper from the square, and then I'm going to be left with the outline of the square minus the area of the circle. So I need to find the area of the square first, and then I'm going to find the area of the circle. But the only thing that has dimensions is the circle. However, I can see that this is a diameter, and if the radius on each side is 3, that means the diameter is going to be 6. So I can also see, with the radius being 3 and the diameter being 6, that this diameter is going all the way across that square, and this diameter would go across the square here. So I see that that square is actually a 6 by 6 square. So I could use the area equals length times width formula under the rectangle, because a square is a type of rectangle, so it works for all of those. And then 6 times 6 is 36, and that's centimeters squared. Or you could have figured out that the area of a square is one of the sides squared. So you could have just said 6 squared. And that would also equal 36. So the area of the square is 36. And then I want to subtract the area of the circle. So I'm going to do the formula for the area of a circle. Underneath here is area equals pi r squared. So pi is 3.14 and the radius is 3. Make sure you don't put a 6 in there because 6 is the diameter. So now I'm just going to change this 9 over here to a 3, and pi times 3 squared, which is 9, is going to give us 28.26. So now I'm going to do 36 minus 28.26, and I get 7.74. And this is an area, so it's going to be centimeters squared. So make sure you utilize all of these strategies when you're going forward with area.